chapter, or this, it's not a chapter, it's part of the same chapter. We're just starting 2.6. Okay, so here's how this works. We're going to start sketching these rational functions that we actually talked about earlier in the year. So when it says label all asymptotes and intercepts, this is not going to be a problem for you, hopefully. This is 1A, because hopefully you remember something about asymptotes. Okay, does anybody remember anything about the asymptotes, where the asymptotes would be for this rational function? This is called a rational function. It's written as a fraction. There's a vertical asymptote, there's a horizontal asymptote. Anybody remember where either one is?
Yeah, vertical.
Exactly. Vertical is tied to the domain. And you know x cannot be 3, and cannot be's are graphed as vertical asymptotes. So you have a vertical asymptote at 3. Your denominator can never be 0. If it is, you have a vertical asymptote. How about the horizontal? This was the one that was a little bit trickier. Josh?
You just look at the x's.
You just look at the x's. That's right. You look right here. And in this problem, we have x over x, so our horizontal asymptote is at 1. That's all old news. We talked about those before. Intercepts are also old news. Intercepts are the points where you cross the axes. And you've been finding intercepts since you were a little kid. Not of pictures like this, but it doesn't matter. You find intercepts the same way no matter what the equation is. Intercepts, remember, are where we cross the axis. So think about crossing the axis. I don't know where this one crosses, but let's suppose it crosses right here. What do I know about that point? It's a point, where my finger is right there, is a point. What do I know about that point?
That's negative x.
Well, I know the x is negative, but I don't know what it is. But what do I know about y?
0.
0. If you are an intercept, if you're sitting on an axis, one of your coordinates has to be 0, right?
Yeah.
So if you're an x-intercept, then the y is 0. Just think about it, look at it. Doesn't that make sense? So if I want to know where that point is, I'm going to come up and I'm going to let y be 0. So if I let y be 0, I have this equation. I'm going to multiply the x minus 3 over to here, but it's still going to stay 0. So where is my x-intercept? Negative 1. So I have an x-intercept at negative 1. And as always, I'll plot that point and label it. Now, think about a y-intercept. I don't know where it is. I just pretend it's where my finger is. Okay? If the y-intercept is right there, what do I know about that point? The x has to be 0. So I'm going to go back to my equation, and I'm going to let the x's be 0. So my y-intercept is not up there. Where is my y-intercept? Put 0 in. What do you get? Negative 1/3. So my y-intercept is down here at negative 1/3. Now that is really all you need in the graph as far as mandatory stuff. But I want to say over and over and over again, if you're not sure what it looks like after you get the mandatory stuff in, the asymptotes and intercepts are mandatory. Once I get those in, you can always plot more points. I mean, like back in the old days when you set up a T-chart, you can always plot as many points as you want. So let x be 2 and plot that point. Let x be 5 and plot that point. Plot as many as you need. After you've done a few of these though, you're going to be done right here. You're going to know exactly what this looks like. This is a variation of the reciprocal function. The reciprocal function is the 1 over x1, remember? And what shape is it? It's the two branches, it's the hyperbola. So this is a version of that. But because of these extra numbers, things have been shifted around. In the reciprocal function, the asymptotes are right on the axes, right? Well, we've moved that by putting in the pluses and minuses and stuff. So, knowing that it's going to have the same shape as the reciprocal function, but it's framed by these asymptotes and contains those 2 points, I think, kids, it's going to look like this, don't you? So I don't really need to plot any more points, but I always can if I need to. But that's it, you're done. Not bad at all, right? So now look at B. B's a little bit bigger problem, but we're going to approach it exactly the same way. It is a rational function, it's a fraction. So what do you think we'll do first with this problem? Yeah, but to do that, what might I do? To start, look at your problem. What do you think you might want to do? Well, factor it. Yeah, factor it. So x minus 1, x plus 1 on the top. And on the bottom, if I take out a 2, I'll have x squared minus 4, which is x plus 2 minus 2. Is that too much? Everybody follow along on that? Took a 2 out of the bottom, and that left me with the difference of squares. Now, if something cancels out, then we got a whole new ball game. Nothing cancels out. Okay? So we're going to graph what we've got, doing exactly what we did over here. There's going to be more of things. So let's start with those vertical asymptotes. This time you have 2 of them. Why do we have 2 vertical asymptotes? Because there's 2 things x can't be. X can't be negative 2. And notice I'm labeling my asymptotes. And x can't be positive 2.
Yep.
Now, to get the horizontal asymptote might be easier to look at the original problem. What do you think the horizontal asymptote is? 1/2? Because we have x squared over 2x squared, right? So my horizontal asymptote is going to be at y equals 1/2. There are a few problems in the world that have more than 1 horizontal asymptote, but they're very, very rare, okay? So generally speaking, you're going to have 1 horizontal asymptote. Now, let's find the intercepts. So how do we find the intercepts again? What do we do to find the intercepts? Yep, you put 0 in, one letter at a time. So 0 in for y would give me, I'm just going to go ahead and erase this and make it a 0 since I don't have much room. But 0 in for y, don't panic. You're multiplying the denominator over there, right? And it disappears. So really, you just have x minus 1, x plus 1 equal to 0, which means x is negative 1 or positive 1. Now what about, those are the x-intercepts.
Do y.
Now to do the y-intercept, we're going to let all of the x's be 0. So if I put zeros in for the x's, I'll have negative 1 and positive 1 on the top, and 2 times 2 and -2 on the bottom. I'm putting in zeros for all of the x's. It might be easier to go back to the original problem and put in 0. There aren't so many x's in the original problem. You can always do that. It doesn't really make any difference though. It looks like my answer is going to be 1/8. Did you get 1/8?
Yep.
So your y-intercept is at 0. Oh no, excuse me, positive 1/8. It's positive 1/8. 0, 1/8. Now, as you do more of these, this is it's gonna become like second nature for you to draw this picture. But I want you to remember that these vertical asymptotes literally split your picture into pieces. So you're gonna have a piece over here, a piece in the middle, and a piece over here. You cannot cross your vertical asymptotes, ever. Vertical asymptotes are untouchable. So that means that whatever's going on here in the middle is completely contained between these two asymptotes. What do you think's going on in the middle there? Looks like a parabola, sure it does. Oh. But again, if you're not sure of that, what can you always do? Plot some more points. Plot some more points. I'm going to take your calculator away. You're going to have to be able to sketch this on your own. So if you can't tell, if that doesn't make sense to you, and it's okay if it doesn't, then you're going to simply plot some more points. So you're going to pick some more x's, plug them in, and see what y's you get, and then put those points on there. Now, you aren't done. There is more to this picture, because you still have something over here and something over here. Anybody have an idea what it is? You don't have any points, but that's a key, believe it or not. Because if you don't have any points here, what does that mean you can't do? You can't cross this axis. Because if you crossed the axis, you would have more of these x-intercepts, right? But there aren't any more. You plotted the x-intercepts. That means I'm not down here, so I must be up here, and I'm framed by my asymptotes. That's what asymptotes do. They're like the walls of the room. They contain the curve. It's gotta look like this, guys. And again, I have this huge advantage because I've done millions of these. But I want you to stop and think about, what other shape over there would you envision? Because it can't be anything that comes down here, because you're not allowed to cross the x-axis. And it's contained by those asymptotes, which means as it goes up, it gets closer to this one. As it goes right, it gets closer to this one. That's asymptotic behavior. So what do you think is happening over here?
Same
Same thing. Same thing. But again, no one is going to sit there and say, oh, I don't know what it looks like. If it doesn't make sense to you, simply plot a few more points, and you'll get it. All right, now we're going to look at our new notes. Because now I've got a little bit, we got a couple more really easy problems. 4 is going to be a little bit tougher, but we have a couple of easy ones here. But I'm introducing some new notation, not new notation, but just notation that we haven't used in this manner before. So let's see if we can figure out what this looks like. First it says sketch it, label all. What label all means? Label your asymptotes and intercepts. All right? So take a look at this problem. This is on page 8 of our new notes. Luckily, I had ready and handed out the other day. All right, here we go. Is it in there? Yeah.
should be in the homework.
Yeah, I think I give it back to you all stapled together for one year. What did I hand you today? Okay. So tell me about this one. This is an easy one compared to the one we just did. This is an easy one.
It's going to equal -3.
Okay, be careful. It actually does equal -3. That's going to be my x-intercept. Because if I set this thing equal to 0, clear the denominator, it says x plus 3 equals 0. So that actually is my x-intercept. Where does the cannot be come from? The bottom. Kids, it's the denominator that can't be 0. So I'm going to have a vertical asymptote at 2. Right? Rory, do you not have this? Okay, I handed them out the other day. Okay, so everybody's with me. We got to get this down. Here we go. Tell me about a horizontal asymptote. 1, y equals 1. So I'm going to label it y equals 1.
You don't keep a line through -3 kind of 0.
No, that's an x-intercept. X-intercept, because when I set my problem equal to 0 and solve it, I get x equals -3. That's my x-intercept. X-intercepts come from the numerator because the denominator disappears when you set it equal to 0. What about my y-intercept? What's my y-intercept? If you put in 0 for x, you get -3/2. Right? Now, this is only our third one, but maybe looking at what you have, you got an idea what it looks like. Certainly, the dots need to be connected, okay? It can't cross asymptotes, but if you got 2 dots on the same side of the asymptote, they gotta be connected. So I am going to go out on a limb and say that part of the graph looks like that. Does that make sense to you?
This is 4.
Yes.
Where did you get y equals 1? Is that just like the
It's
2
the-
x's?
Yes, it's the horizontal
Okay.
asymptote. That's how we find horizontal asymptotes. Okay? Now,
Okay, thank you.
what about the other part of the graph? Don't forget, you gotta have something on the whole picture. Okay? There is a type of function that you don't have something all the way across, but it's got radicals in it. If there's no radical, you're gonna have all the way across. So what's happening over here? Same thing, but it's up here.
Yeah.
Now, I want you to see something. If you tried to do this, which would be another option, it's framed by the asymptotes, that would be another option. That's impossible, because see that right there? That's an x-intercept. And you already graphed the only one that you have. So this can't possibly be the picture. Even though it would be reasonable to have a shape like that over there, it can't be in this problem.
And can you not do it on the other one because you already used the y intercept? That's you have your own.
Yeah, I mean, these
Y-intercept?
have to be connected. So
Yeah.
yeah, I don't have any choice over here.
Oh no, on the top one.
If I tried to do that, it would be a function.
Okay.
You can't put pieces on top of each other.
Okay.
These are functions. They have to pass the vertical line test, right? So you're never going to have something on top of something else. All right, so that's the picture. Now, let's look at all these questions then. We talked about end behavior before. And really, that's what the first two, A and B, are their end behavior relationships. Because we're saying, what happens to this picture? What happens to this picture as x approaches infinity? Now, tell me where to stand. Should I stand here, or here, or here, if x is approaching infinity? Where would be the place to stand? Position 1, 2, or 3, if I'm demonstrating where x is approaching infinity. Position 1, because isn't this infinity, people?
Yeah.
So this is asking me, what happens to the curve when you go all the way out here? Well, tell me, what is happening to this curve as I go all the way out here? What is it doing? What are those points doing?
Getting bigger and
It's
bigger.
getting closer to the bottom.
It's getting closer to what? 1.
Y
Isn't it
equals
getting
1.
closer to y equals 1?
Mhm.
So we say 1 and put a little plus sign there, because that little plus sign tells me that I'm coming at 1 from the top. It doesn't mean positive 1. This is positive 1. This means I'm approaching it from the top. Because other graphs might approach like this, right? Not this one, but this would be approaching from the bottom. Okay? Now, I kind of messed it up here, but this is negative infinity. Where do I look if I'm approaching negative infinity? This tells you x is going to negative infinity. That's here on the whiteboard, or whatever that is, that board, right? So what's happening to your curve as you go that way? Aren't you approaching 1 again?
Yeah.
But this time you're approaching it from the bottom. So that's going to be 1 with a little negative sign. That just tells me I'm approaching 1 from the bottom. Okay? Most calculus classes are really big on graph analysis. And what they'll do is they'll give you a whole bunch of information like this and tell you to sketch the graph. So you have to understand what this notation means. This means I'm going left, and my points are getting closer to 1 from the bottom. All right, so then it says, and there's a couple more, these are not end behavior. As you go to negative infinity and positive infinity, I mean, obviously that's the ends of the picture. This is as we're approaching 2 from both sides. I have no idea. That should not be a negative 1. That should just be a negative sign. I won't carry away there. So erase, that is not 2 to the negative first. That should be just 2 to a negative sign. That is my mistake. All right, so let's look at our graph. Right here, right here is where x is 2, right? So this is asking me, what happens to your function, what happens to your picture as you approach 2 from the right side? We can approach 2 from both sides, so this is specifying right side. So here I go. Here's 2. This is the right side. I'm approaching it. What is happening to my curve as I get closer to 2 on this side?
Goes to infinity.
Goes to positive infinity. Goes up. Now, what happens as you approach 2 from the negative side, the left side? It goes down. So this is really describing what happens with your horizontal asymptote And this is describing what happens with your vertical asymptote. All right, good work. Let's try the next one. Okay, so our function is, all right, so while I'm getting all this stuff copied down, why don't you see what kind of progress you can make on your, I'm getting it sketched. So your asymptotes and intercepts. While I copy down all the rest of this.
Yeah, well, it's a pretty nice schedule now. Hi, Mike. Thanks, Kathy. Hi. How are you?
Good, how are you?
That's a dream, it's okay. You can tell them it's okay that I was reading to you. Oh, sorry, I was talking to one of your.
Anybody put a vertical asymptote in yet? Where did you put your vertical asymptote?
-2.
X equals -2, yep. And you labeled it X equals -2. Perfect. Anybody put a horizontal asymptote in yet? Y equals 2, positive 2, Y equals positive 2. Now, does anyone have a question about those two things? All right. Anybody put a Y-intercept in there? A Y-intercept, a point on the Y-axis?
0, 1/2.
It's 1/2, yep, 0, 1/2, 0, 1/2. Again, if we're on the Y-axis, X has to be 0. There is no X. So if you put 0 in for the X's, you're going to get 1/2. All right? What about your X-intercept? That's going to be -1/2 because, comma 0, remember we're labeling our point, -1/2, comma 0. If you set Y equal to 0, if you put in 0 for Y, and you have to solve this equation, you're going to multiply both sides by X plus 2, and it's just going to disappear. And then you're going to solve for X. Subtract 1, divide by 2, -1/2. So, based on that, can you fill it in? Can you sketch it? It's going to look like this. And like this. Would you agree with me? Is that what it looks like? Caroline, you okay? I'm not sure what's on your iPad there. You're not watching it, are you? Okay, good. All right. Now we got to answer our questions over here. So once we have the graph, that's easy. Liz?
Wait, I'm confused why you put this up there, the second part of the diagram.
This part?
Yeah.
Where did you put it? Okay, we really only have two choices because the curve is framed by its asymptotes. So your two choices are really that or this. There isn't really anything else it could do because it has to approach the asymptote as it goes up or down, and it has to approach the asymptote as it goes to the left. So there's really nothing else it can do. It couldn't have, it can't be this one because it can't cross the axis. Can't, because that's the only place it can. It can't have a parabola type shape because it must approach the asymptote as it heads off the page. So, I mean, I can't really help you unless you tell me what you think it might be, because it can't be anything else. So, if that's confusing to you, it's okay. You're just gonna plot a few more points. Because if you plotted, this is -2. If you put in -3, -4, -5, you would know exactly what it looks like. You just have 3 more dots, you can connect them, okay? But it's really, really important for you to remember, for all of you to remember, oh wait, that's what I keep, that you cannot cross a vertical asymptote, ever. Horizontals actually can be crossed. Verticals cannot be crossed. And the picture absolutely must approach the asymptotes as it leaves the page. So if you were to continue drawing till you went off your paper, you gotta be getting closer to the asymptote. Whether you're going up or whether you're going out, you're getting closer to the asymptote the farther you go. Okay? So even if it did cross its asymptote, it would do a wobble across it and would still be getting closer to it as it went off the page. All right, so here we go. This says, as we go to the right, what is my function doing? Well, as I go to the right, isn't it going up?
Yeah.
And it's going up and getting closer and closer to 2, but it's coming in from the bottom. So don't write -2. That's a whole different thing. That's down here. You're saying I'm heading toward 2, but I'm coming at it from the bottom. Now this says go left.
2.
X approaches -infinity. Left. As we go to the left, our picture is still getting closer to 2, but now it's coming down from the top.
Yeah. 2 plus.
Now, this right here tells you exactly where you're looking. X is approaching -2. That's our asymptote, right? And it's approaching from the right side. So what happens as you approach that asymptote from the right side? Get closer and closer and closer to that asymptote. What's happening to your curve?
-infinity.
-infinity. You're going down. So what does this say? Same thing, but now you're coming at the asymptote from the left. So as we come to toward the asymptote from the left, as we move toward it, we're going up, right? Wherever.
Positive infinity.
Positive infinity. So really, once you have your picture drawn, just do what it says. Let X go to infinity. Go this way. Follow the curve. Right? And then same thing with all the rest of it. Okay? The next one is going to be a big, big deal. So I think this would make a good time to break for lunch. Sad day, it's your last group lunch. So let's have everybody back ready to go at 12:30. And I mean, we got to start at 12:30 because this problem's going to take us a while to get back. All right? So you guys need to be back, ready to go at 12:30. So don't join at 12:30. Be ready to go at 12:30. Okay? All right. See ya. Have a good lunch. Those of you, here's our lunch bag. I saved one the other day. Those of you going need to sign out. Today is 11:15. There you go. Well, then it's got COVID. It's germs on it.
She's like, yeah, just record yourself and send it to me. ACP public speaking.
Yeah.
That'd be nice. She was like,
Yeah, and you won't have to say it in front of other people.
Yeah.
I bet you'll have to do it on Zoom. don't you?
Saunders.
What did you say?
I was so clapped. Dude, I got in my car and I was just like, out in the parking lot for like an hour and a half.
That's like the best part.
Jack O'Connor came out like an hour and a half later and they were just playing Minecraft there. Saunders left. Like an hour and a half.
Oh yeah.
Yeah, no, I almost came in there. Because you guys were playing down there, right?
Yeah, no,
That was so long.
we got Mr. Saunders' Discord, and I have my Discord, and we have Owen's Discord, and we made a Minecraft lobby, and he's buying,
So you're getting a realm?
yeah, he's getting realms, and then we're all gonna play
bro, let me
during our
hop on.
period. Yeah, yeah,
'Cause
then we'll hop on.
I
It's gonna be
claimed
so
that, because
fun.
you were playing on that server, right? Because I claimed that
Yeah.
temple.
Okay, yeah,
That's
you
my
did.
house.
Okay, yeah, there were lamps by. I was like, why are there torches by?
Did you start building your house?
No,
Oh.
because we're done with that one. Because we have to go to a new one. Because it's
Oh.
tanks.
So just ruining
Dude, we
everything.
died like 80 times in the nether. We were trying to get our stuff back from the first time we died. Oh, no, it's still on. Sorry.